Hello, welcome to Math. So, integral ln x over x squared dx. So, integral ln x over x squared dx. Let's write our solution. Let's repeat this one. Now here, we are just going to rewrite this one using negative index law of indices. Okay, so if you apply the law here, we are going to get integral x raised to the power minus 2 multiplied by ln x dx. Okay, so let's rewrite. Okay, so let's apply the law. Now when you use the law, it's going to give you x raised to the power minus 2 multiplied by ln x dx, all because the law states that 1 over a can be written as a raised to the power minus 1, or a raised to the power minus 1 is equal to 1 over a. Okay, so here is an integration apart question. Here is an integration apart, but we are not going to use the traditional method here. Here in this video, I'm going to use DI method. DI method. The DI method means differentiation integration method, and it works the same as the traditional method. Okay, so now when you're using the DI method, you have to decide which of them to differentiate and which of them to what integrate. Okay, so am I going to differentiate this one, or integrate this one, or differentiate this one, or integrate this one? So you have to decide which of them to differentiate and which of them to what integrate. Okay, so here well, I will choose to differentiate ln x and then integrate x raised to the power minus 2. Okay, so let's write. Now when you're using the DI method, you have to create two columns. One will be for D, which is differentiation, and the other column will be for I, which is what? Integration. Okay, now the rows involved in using the DI method are positive and negative rows, but we always start with what? A positive row. And when you start with a positive row, the next row has to be what? Negative. The next row has to be what? Positive, and then it follows in what? That order. Okay, so we are just going to differentiate ln x in the first row, which is what? A positive row, and then we integrate what? X raised to the power minus 2. Okay, so let's write. Now as I said, the first row has to be positive. Okay, so here we are differentiating ln x, and then we are integrating x raised to the power minus 2. Okay, so now let's differentiate and see what you get. And when you differentiate, whatever you get, you just write it in the next column, which is what? A negative column, because the first one is positive, so probably the second one has to be what? Negative. Okay, so let's differentiate ln x. When you differentiate ln x, we are going to get 1 over x, 1 over x, and then when you integrate x raised to the power minus 2, we are going to get minus x raised to the power minus 1. Okay, so let's write. Now when you are using the DI method, there are three steps, or three approach, or three ways in using the DI method. Now we stop when you get 0 in the D column. We stop when we get 0 in the D column. That means when one of the differentiation what gives a 0 answer. And The reason why we are stopping there is because when you multiply that um, row where you had the 0, we are just going to get what? 0, and there will be nothing to be further what work on. That's why when we get 0 in the D column, we stop. Okay, and also we stop when we realize that the product of a row can be integrated. Now, when I say the product of a row, please don't just go and multiply the first row. No, the first row is what? Not we don't use the first row. If you use the first row, you are wrong. Subsequent rows after the first rows, any row that you get, any additional row that you get, any of them that you multiply, that can be integrated easily. You just stop there. Any of them that when you multiply and it can be integrated easily, you just stop there. Okay, but please take note, don't use the first rule. Don't use the first rule. Okay, and also we stop when a product of a row generates the original question. Remember, I said subsequent row, not the first row. The first row is what? Not part, but the subsequent rows. So as I was saying, we start when the product of a row gives the same question or gives the original question. Example, assuming this one were to be in the second row, we will just stop because when we multiply this and this, it will give us what? The same question as what? The original question. Okay, and when that happens, solving that particular question is what's easier because you just add it to the original question and then you just divide both sides by whatever you get and then you are good to go. Okay, so now here, now that we know ways of using this DI method, here we are not going any further. We are just stopping because we can easily integrate the product of this row, which is 1 over x multiplied by minus x raised to the power minus 1. Okay, now someone may also ask, after using the DI method, how will I get my answer or how will I generate my answers? Now, to get your answers from the DI method or the DI format, you just have to multiply the product of the rows, product of the diagonals. When I say product of the diagonals, all that I mean is when you take this first one, you take maybe you take 1 from the first row and then you multiply it with the other one in the second row under a different column, but not in the same column. So this ln x under the differentiation column will multiply minus x raised to the power minus 1 under the integration column. Okay, so the product of the diagonals are what? Your answers. When you multiply, whatever you get are what? Your answers. Okay, so our first part of the answer that we are looking for is going to be the product of this and this, which is indicated in this red arrow. That means this and this, when we multiply, will give us the first part of answer that we are looking for. And also, when you are multiplying, please don't forget the operation sign written along them. This plus is affecting the whole of this row, but that does not mean, assuming this is negative, you will not um, you will not use it when you are multiplying the product of the diagonals, when you are multiplying the diagonals, or when you are using it to multiply the other one in the other column. No, though this column is positive, but if this one is negative, you just take the whole of that negative and then you just multiply with whatever is being written here and you are good to go. Okay, so this times this is going to give us minus x raised to the power minus 1 multiplied by ln x, and that is what the first part of the answer that we are looking for. Now the second part of the answer is what we are going to further work on because we choose to start. So the second part of the answer is going to be the product of this row, which is indicated in this blue parenthesis. So that is 1 over x multiplied by minus x raised to the power minus 1. Okay, so let's write. Now when you multiply this and this, we are going to get minus x raised to the power minus 1 ln s. And then when you multiply this and this, remember this negative is affecting everybody. When you multiply this and this, we're just going to get plus integral 1 over x multiplied by s raised to the power minus 1. Okay, so let's write. Here, we are just going to maintain this one and then we further work on this. Okay, so let's write. Here we are just going to change this one. Okay, so we are just going to change this one using the negative index law of indices. So this one can be written as s raised to the power minus 1. Okay, so let's write. Here the bases are the same, so we just add the powers. Okay, so let's write. Now when you add the powers, you are going to get s raised to the power minus 2. Now to integrate this, we just add 1 to the power and then we divide the whole of this with the what? The power. Okay, so let's write. And now this one will just give us s raised to the power minus 1 divided by minus 1. And this one will give us minus s raised to the power minus 1. Now let's add this one to the other answer and then let's simplify. Now let's open the bracket. Now here, to simplify this, we just use the negative index law of indices. A raised to the power minus 1 can be written as 1 over a. So this one can be written as ln x over x, and then this one can be written as 1 over what? X. Okay, so let's write. Now here we just add the numerators because the denominators are the same. Okay, and that's going to give us minus ln x minus 1 all over x. Okay, so let's write. Therefore, this will be equal to this one plus c. Therefore, ln x over x squared dx is equal to minus ln x minus 1 all over x plus c. Okay, all right, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.